Hello everyone, welcome back. Let's discuss this problem, first and last occurrences of x. So we are given a sorted array of size n and we will have to find the first and last occurrence of x. So in this example, we are given an array of size 9 and we will have to find the first and last occurrence of 5. So the output is 2 and 5. Let's take this example. The element we will have to find is 7. So the first occurrence will be 6 and the last occurrence will also be 6 because there is no other 7 present in the array. Also, we will have to return both indexes -1 if the element is not present in the array. Correct? We will have to store the result in a vector as it is given here. The return type is vector. So we will have to store the result in a vector. Okay. So let's discuss the nice solution. So the nice solution is simple. We will iterate through the entire array with a for loop, and we will check the first occurrence of the element x in the array. When we get that, we will push that into the resultant vector, and then we will iterate further. Then we will check if the element is equal to x, then we will check if the next element is not equal to x. If it is not equal to x, then that index, the previous index, will be our last index. So we will store that also into the vector and we will print the final result. I'm not coding the this naive solution because it will anyway give me time limit exceeded error. So I will go to the better approach, that is binary search. As the array is also sorted, so we can use binary search and it will take big of log n. So in the next previous video, I have explained binary search algorithm, how it works. So I will put that video in the description box and you can check that. So let's come to the solution of this problem. So in the binary search, what we do, we take three variables. That is, first will be low and the second will be high. High will be n minus 1 and the low will be the first index, so it will be 0. So mid, I will initialize it inside the while loop. So now let's initialize the vector, which is our result. Then we will start the while loop. So what was the condition? Condition was while low is less than equals to high, so that we iterate through all the elements. Now we will initialize mid. So our mid will be low plus high divided by 2. Okay. Now our first condition will be if array of mid is equal to x or not. Then our second condition will be else if x is greater than array of mid, and also else. So in else if, what we will do, we will change our low because our element x is greater than array of mid, so we will have to parse through the right side of the array. So we will change our low, so our low will become mid plus 1. Similarly, if it is less than array of mid, so in that case we will change our high because we need to iterate through the left side of the array. So in that case our high will be mid minus 1 and low will be same. Now I will be using here two while loops. Okay, two times I will use the binary search. So first will be for the first occurrence and then I will explain the last occurrence. So let's first do the first occurrence. So for first occurrence, here in this example, our n is 9. So low will be 0 and high will be 8. So our mid will be 4. So this is our mid. So this is not the first occurrence, but array of mid is equal to x. So we have satisfy this condition, but this is not our first occurrence. So what we will do, we will check, we need to iterate in the so definitely our first occurrence will be in this part, first occurrence will be on this part. So what we will do, we will first check if the previous element, that is array of mid minus 1, is not equals to x. If it is not equals to x, then this will be our first occurrence. So we will push our mid into the result because that is our first occurrence, and we will break through the loop. But if it is equal to x, like in this case, here mid minus 1 is also equal to x. So we will do here, we will change our high because low will be same. We are iterating in the left part, so we will, our high will be same. Sorry, our high will be, our low will be same, so our high will change to mid minus 1. So this is how we will get the first occurrence. I hope it is clear. So I will copy this loop and I will paste it again here. This will be for our last occurrence. So same thing I will do, just a little bit of modification is required in our this part. So first I will just initialize again. I will just put my low and high again. Low equals to 0 and high will be n minus 1. And now we will just change here. So this is our mid again. Now for last occurrence, obviously I will have to go through this part. So I will check array of mid plus 1 here, and if it is not equals to x, then definitely array of mid will be our last index. So we will push that into the result and we will break. If it is not equal to x, then what we will do, we will change our low in this case because high will be same. So our low will change because we are iterating in the right side. So low will change to mid plus 1, correct? And this is how we will get the last occurrence. And then finally we will return our result. Okay, so we got the first occurrence and the last occurrence. But we need to have another thing, which is that if x is not found in the array, what will we do in that case? This program will not be doing that, handling that case. So in that case, what we will do, after the first loop, after the of checking the first occurrence, we will go and check if our result is empty or not. Why we will check if our result is empty or not? If our result is empty, then that means that we have not found the element in the first occurrence. Correct? That is, we have not found the element in this entire array. So that means there is no need of moving further. So what I will do is that I will simply push back minus 1. I will have to do that again, and we will return our result. I hope that's clear. Suppose yeah, so I hope that is clear. So in this loop, if we don't get the element x, so that definitely we don't need to check for the last occurrence. First occurrence we have not got, so we don't need to check the last occurrence. So we'll check if the result of size is 0 or not. It will be 0 if we don't get, so we will push back minus 1 twice and we will return the result. And if it is not, then definitely we will initialize again low 0, high n minus 1, and we will check the last occurrence and we will return our result. So let's compile and run the sample test case and see. So we have passed our sample test case. Let's submit the solution and see. So we have passed all the test cases. So this is an application of binary search. As we can see, we have used binary search and we have successfully compiled all the test cases.